Hi, hello, everyone. So this is Ravinder Pasula. Now I am going to discuss about regression analysis. Now, agenda for today's lecture. We'll discuss about what is regression, what is linear regression, and types of linear regression. Understand the linear regression concept. And lastly, we'll discuss about the use case or applications of linear regression. Now, first of all, what is regression? Regression analysis is a form of predictive modeling technique which investigates relationship between independent variable and dependent variable. That is regression analysis. So this regression analysis to explain that independent variables have on the dependent variable, I'll repeat once again. It explains the influence that how much independent variable influence on dependent variable. That means outcome variable. So that is regression analysis. Now questions, will raise in the regression analysis, or the questions regression might answer. That means the first question is, what is employee salary? That means, after present today my salary is 50k. Now what my salary after 2 years? So that is what predicting my salary after 2 years, 3 years. The same thing, what is probability and application on default on a loan? So that we can predict how many parameters, inputs can affect to default and applicants. So that is what predicting. Now, uses of regression. There are major 3 uses are there in regression analysis. The first one, determine the strength of predictors. By using regression analysis, we can predict the demand forecast, salary, the how many students will get the employee in upcoming years, like. And coming to the forecasting and effect. And third one is trend forecast. Linear regression model that represents the linear relationship between a dependent variable and independent variable. Now in this picture, now here, so these are some points, data points, and this line is nothing but what? A line of regression, right? Now the x-axis contains independent variable, that means independent inputs. What inputs influence on outcome? So this part is what? Outcome. That means dependent variable. So dependent variable means what? Outcome. How much outcome we are predicting. So this outcome depends on the independent variable. So these independent variable may be 1, 2 or 3 or more. If the sloped line representing the linear relationship that fits the given data best is called as regression line. So out of these many points, so we have to draw the best fit line. That is what a regression line. Now coming to the types of linear regression. So based on, the number of variables affecting on dependent variable outcome, based on that we can categorize, we can divide the linear regression into 2 types. The first one, simple linear regression, and second one, multiple linear regression. That means if independent variables, input variables, if it is 1, that is comes under linear regression. If dependent variable, so this is what independent variable, this is independent variable. If independent variable, if it is 1, so that is simple linear regression. If independent variables are more, then that comes under multiple linear regression. Yeah, coming to the first category, simple linear regression. Here the dependent variable depends only on a single independent variable. Okay, now for a simple linear regression, the form of linear regression is like this. Now this one is the form of simple linear regression. Now here that output y, it is dependent variable. It depends on only in one independent variable. So this is the simple linear variable. It has only one independent variable. For example, here this one, right? So here this is what independent variable x, and this one is the dependent variable. So if independent variable only one, that is what simple linear regression. Now here these two are variables. The B1 is the intercept or the bias that fixes the offset to a line. And coming to this one, is the slope or weight that specifies the factor by which x has an impact on y. Yeah. Now here again, the regression lines are 3 types are there. Depends on the value of that, the B1. So this formula, whenever is less than 0, whenever it is less than 0, that means it indicates that variable x has negative impact on y. So this statement indicates, that means if x increases, y will decrease and vice versa. So this is what case 1. There are 3 cases are there in simple linear regression. Now here, once x is increases, now what about y? Y will decrease. So that is what case 1. Now what about the line indicates? The best fit line indicates. The best fit line will comes down. Yeah. Now as per the case 1 here, so whenever the independent variable increases, automatically that dependent variable will decrease, right? So in that way, the regression line will comes down like this. So this is what case 1, it's negative impact on y. That means whenever independent variable increases, automatically that independent variable will decrease. That means indirectly independent variable negative impact on dependent variable. Coming to the case 1 is equal to 0. Here it indicates that the variable x has no impact on y. That means even if x changes, it never impacts on y. Yeah. So this figure indicates even x increases, it doesn't affect on y. So this is the formula of what? A linear regression, simple linear regression. Now coming to the this case 2 here. Now whenever y increases, x increases, I'll repeat, whenever independent variable increases, automatically what happen? that dependent variable will decrease that negative impact on, dependent variable. Now coming to the third case. Now whenever it is greater than 0, now it will be, positive impact on y. That means whenever x increases, y will increase and vice versa. That means positive impact on dependent variable. Independent variable will influence in positive manner on dependent variable. Yeah, so this is the formula of simple linear regression and according to the third case. Now here, whenever independent variable increases, automatically the dependent variable also increase. Yes. Now coming to if you want to plot the coordinates on the x-axis and y-axis according to the simple linear regression. Now here the value of x is 1 and value of y is 3. Right. Now if you are trying to plot, so here automatically, yes. Now what about x value is 1 and what about y value is 3? Yes. So here x value is 1 and y value is 3. Now both are plotted. So like we have to plot all the variables, all the data points in these x and y coordinates. Now take the second variable. For example, here 2 is there. Yeah, 2. Right? 2 and what about y value? 4. Yes. It will increase to here. The next one, x value is 3 and y value is what? 4. Now coming to here, x value is 3 and y value is 2. And coming to the x value, that next data point in x-axis, that means independent variable is 4. And what about the value on dependent variable 4? Now if you do this one, 4 and 4, as here the x value is 4 and y value also 4. The last one, the value on x-axis is 5 and the value on dependent variable, y-axis is also 5. Right, if you combine like this, we'll get here. Now after plotting all the data points on both the y-axis and the x-axis, now once you're trying to plot the line, the best fit line, so here, yes, so this is the best fit line. So this line indicates a line of regression. So in this way, we can plot the best fit line among all the data points of both the x-axis and y-axis, also referred as independent variable and dependent variable. So like we can plot a best fit line. Now coming to the understanding the linear regression. Now, yes. So here these are all data points and we plotted the best fit line. So these are independent variable and dependent variable. So all independent variable influence on dependent variable. That may be, negative impact or positive impact or doesn't impact. So there are 3 cases are there. Already we have seen those 3 cases. Yeah. So these are what observations, data points. Now here, after plotting all the data points, once you draw, so these regression line. Then after that, we have to find out, mean square error. And simple regression analysis, after plotting the best fit line, then we have to minimize, we have to find out mean square error. That means the distance between, the actual point and predicted point. If that distance between actual data points and predicted data points, if it is more, there's not a, that is what a bad fit line. So in order to reduce the distance between, actual the actual value and predicted value, we have to apply some methods, that is mean square. So we have to minimize that error. Okay, now this is what estimated value. This one is what? Estimated value. Okay, so this one is actual value, this one estimated one. So this gap is what? Error. So we have to reduce this error. We have to minimize the error. So by using, that is what mean square. By using mean square method, we can reduce the distance between estimated value and, actual value. Now coming to the multiple linear regression. Already we have seen, the first method under linear regression. The first one is what? A simple linear regression analysis. In that, independent variable contains only one. That independent variable, impact on dependent variable. That may be, it doesn't impact on independent variable. If it impacts, that may be positive or negative. Now, what happens if independent variables are more impact on dependent variable? That is multiple regression analysis. Now, so in multiple regression analysis, the dependent variable depends on more than one independent variable. Yeah. The form of this model is like this. Now here, there are more number of independent variables are there. Now these are, one independent variable, and this one is second independent variable, and third independent variable, and so on. X number of independent variables are positively or negatively impact on dependent variable Y. That is multiple regression analysis. Yeah. Now here, Y is a dependent variable, x1, x2, xn are independent variable, and b1, b2, and so on, n are regression coefficients, right? So it is, a slope one. It is the slope or weight that specifies the factor by which xa has an impact on Y. So this indicates what multiple regression model. Now coming to the use cases. So there are many applications are there by using, linear regression. Now first I will tell you a real estate example. So real estate, which predict residential home prices. So once you predict residential home prices, so these home price depends on many inputs. For example, we can that, once you try to identify independent variables to predict the home price, so one may be, number of, bedrooms. There is one independent variable, and second one, floor. At what floor you want to take a flat, and area, the area of the flat you are going to buy, and the fourth point, location. So these many parameters are there to predict a residential home price. Now coming to the demand forecasting example. Yeah. Now, in demand forecasting example, the restaurants. Restaurant predict food quantity. How these restaurants predict food quantity? So that is, very, very important in hotels, dhabas, restaurants. How we can predict. So that is what a demand forecasting example. Compared to seasons here, winter season, rainy season, and summer season. Once you analyze, compared to summer season, the people doesn't move out to the market, in rainy season as well as winter season. So that weather impact. So because of weather conditions, the people doesn't move out. But compared to, in summer season, the people move out. So based on that, if more people are there, if more people move out, so definitely the more quantity of food we need. So based on that, we can predict how much food we require. So this is what use cases of regression analysis. So by this, I'm concluding the simple linear regression. So once again, here, so what we studied in this video, we studied about what is regression. So regression is it's a part of the supervised learning algorithm. Already we have seen three different types of learning algorithms: supervised, unsupervised, and reinforcement learning algorithms. Now this linear regression comes under supervised learning algorithm. We discussed about types of linear regression and use cases. Now by this, I am concluding the session. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.